Hello, and thank you for having a look at this playlist. It's an introduction to scanning MA-XRF data evaluation with a special focus on historical paintings. Now, as a warning, this is basically an online form of the tutorial I'm giving at the International Conference on X-ray Optics and Microscopy 2017 in Trieste. So this tutorial will describe the how to evaluate MA-XRF data and not what we do and not why we do it. I assume knowledge of XRF imaging and will not explain the fundamentals of the method, mainly because in the workshop I have 3 speakers before me that will do that. So, who am I? I'm Matthias Alfeld. I have a degree as a Diplom-Chemiker, Master of Science equivalent from the University of Hamburg. I did my PhD at the Universities of Hamburg and Antwerp in the development of scanning MA-XRF for the investigation of historical paintings. Afterwards, I worked as a postdoc and beamline scientist at the Deutsches Elektronensynchrotron in Hamburg, and currently I'm junior chair at the Laboratoire d'Archéologie moléculaire et structurale at the Sorbonne Universities in Paris. My PhD thesis, which I did from 2008 to 2013, mainly at the University of Antwerp in the group of Janssens, pioneered XRF imaging of entire historical paintings. I did not do the first scans, but I developed the first practical mobile instruments involving the mechanical and software design. I researched the workflows for data evaluation and published that as open source. And I applied these software and these instruments for the investigation of historical paintings, some of them by Rembrandt, Caravaggio, and Van Gogh. Also, I wrote an invited review paper. So, a very successful PhD, and this is what I'm going to talk about today. So, the content of this playlist is my personal data evaluation workflow for the investigation of historical paintings. There are 7 parts, and the first 3 parts deal with PyMCA. Parts 3 to 7 are based on my own work, which I published in this article down here in the Journal of Analytical Atomic Spectrometry. Now, why is there a data muncher? Now, when I started my PhD, I used systems developed by Dr. Bart Wigmans at the University of Antwerp in the late 1990s. There, each pixel was saved as a separate ASCII text file, which resulted in huge data size and long access times to these data. Also, the data was fitted with Axial, which ran only on the group server, and this meant that we needed to transport the data. Here you see Axial in all its glory, 16 colors, and the graphical user interface developed for it. So processing the data meant zipping several 10,000 of ASCII files, copying them to an USB disk, bringing them to the server, unzipping and fitting them there, and more than 3 hours per scan were at times needed for this. My frustration with the situation reached its maximum when I processed the data of Pauline. Now, this is Pauline im weißen Kleid, with a controversial attribution to the German artist Philipp Otto Runge, and it's part of a private collection. We took this painting to the Deutsches Elektronensynchrotron in Hamburg, Germany, to scan it there at the synchrotron radiation source, and it took us 3.5 days. Now, what we found there is that under the surface she was shown with open, long, probably brighter, maybe even blonde hair. But you only see the final image, there's some problem with it. For several reasons, we took in total 7 scans to acquire this image. And now processing this data, step by step, meant always starting the process manually anew. And so I fitted the torso, I fitted the face, and then I came there and I noticed that there are chrome-containing repairs. And as I only noticed them in this spot, I could not be sure that they were not also in the other scans as well in very minor details. So I needed to reprocess the entire data set, which took me 2 days, left me very frustrated with the will to improve. And so I developed Data Muncher, a graphical user interface to eat through the data. And originally it was just a graphical user interface to organize the data and start axial batch jobs. That was all it was meant for, but things went on. I had already heard about GeoPXE in 2009 on a conference. I thought it sounded a little bit ambitious. Then I had 2 beam times at the National Synchrotron Light Source at the Brookhaven National Laboratory in the United States, where they worked with GeoPXE, and I was impressed by the speed of it. Now, the base of it is that you can express linear regression as a matrix multiplication. And a matrix multiplication is a very fast operation on a PC, so you can really accelerate data evaluation by implementing that. Now, as a chemist and not a mathematician, it sounded a little bit fuzzy to me, honestly. And I didn't believe it would work, and so I did the best I could do. I took the papers by Chris Ryan, read them carefully, reintegrated that in my software, and tried to prove him wrong. But actually he was not wrong. It is a very fast and efficient way to treat data, and so I integrated this into Data Muncher. There was only one problem. I needed elemental profiles. This is basically how you calculate this tau matrix here, and how to get them. Now, the mathematics is out there, and it would have been possible to just take it from the textbooks, put it into a program, and then finish it. However, I have not seen further. If I have seen further, it is by standing on your shoulders of giant, as Isaac Newton said. Or better, no one is going to congratulate you for reinventing the wheel. So I went to PyMCA, which means that I always need to use it along with my own software. I need to explain it along with my own software so that people understand how they use it. However, I'm not the developer of PyMCA, and the developer of PyMCA has his publications there, which should be cited if you use Data Muncher with it, and they also have their SourceForge page. Now, PyMCA is based on mathematics similar to Axial. It's open source, and it offers a modern graphical user interface to process imaging data. However, before 2013, it was too slow to fit the large datasets I acquired in my PhD. So I used it along the way, I used parts of it, but it never was for me then a satisfying solution for these huge datasets. And also today, if you have a large dataset that you need to stitch, starting several fits takes its time and makes it for me rather frustrating to use. So, originally Data Muncher was just a graphical user interface to start axial batch jobs. Then it became a graphical user interface also to start PyMCA batch jobs. After that, it became a graphical user interface to run dynamic analysis based on PyMCA fit profiles. And finally, I added other functions I needed for the evaluation of scanning MA-XRF data of paintings. And all this is integrated there and available as open source. You see it down there. You can download it, install it, and use it. So I have to thank many people that helped me, but especially it's Bart Wekemans, who developed Axial. When I was an Erasmus student in Antwerp in 2006, he was my supervisor. He introduced me to programming and had a huge impact on me and my further career. And I have to thank Wout de Nolf, who helped porting Data Muncher to Unix systems, such as the Mac version I'm using now. I hope you enjoy this video series, and if you're interested in the development of scanning MA-XRF and the ongoing things, you can look up and cite my review papers. The first from 2013 during my PhD with my PhD advisor, José Bruckert, and the second one from this August, which I wrote with my colleague Laurence de Viguerie. So, thank you for your attention and enjoy these videos.